This festival is celebrating European biomimetic robotics. We brought together 13 different robots from across 7 countries, and they're all going to be here at the Science Museum during the festival. Biomimetics, I think, is a really interesting field, how we're losing something really technological, but we're looking at how nature, something really organic, can really inspire new solutions in technology as well. So we have lots of different robots here on display. The one that's next to me is the Arrows team, so this is a deep sea archaeology robot, and they are exploring the underwater tank. We also have robots in our jungle habitat. So we have the Plurobot, which is based on a salamander, and you can see him walking up and down.
My name is Plurobot. My design is based on the salamander skeleton.
What you see here is Plurobot, is our latest generation salamander robot. So it's very closely based on the exact bone structure of a real salamander. So we had the chance to make X-rays movies of a salamander while it was walking, swimming, and from that we could very accurately record all the motions of the bones. And based on that, we designed a robot that can closely reproduce the swimming and the walking behavior of the robot. We love to see a salamander-like robot that we could use for inspection or after a catastrophe like a tsunami or an earthquake, to have a robot that can crawl around, swim, walk, depending on the conditions, to see if they're survivors. And this would be a very nice remote-controlled robot that can kind of crawl around and see in kind of dangerous places if they're survivors.
So here you can see this robotic system in action, which is part of this StiffLop project. And the title of the project is most appropriate, because the idea is to create something that can be either stiff or floppy. So here you can see our StiffLop arm that is moving about inside this mock-up of a patient's body. And that is our idea to be the new tool for surgeons in operating on patients.
I'm Peter Eckert from the Biorobotics Laboratory in EPFL in Switzerland, and this is Cheetah, one of our quadruped robots with the bio-inspired leg design and a nice link between biology and ingenuity. 7 body lengths per second makes it the fastest robot, to our knowledge, under 30 kilograms in relation to the robot size.